Hello. So last class we discussed about basic properties of gamma and beta function. Now we are going to solve few problems based on beta and gamma function. The first one is prove that 2 power n gamma of n plus 1 divided by 2 equal to 1, 3, 5 and so on 2n minus 1 into root pi. So we know gamma properties, some of the gamma properties. This is the one of the important gamma property. Gamma of n plus 1 equal to n gamma n. So I'm going to using this formula. First step, I need to substitute here the n plus 1. Then I'm going to write this one. Gamma of 1 divided by 2 minus 1 plus 1. Now I'm going to simplify this one. This one gamma of minus 1 divided by 2 plus 1. Now I'm going to use our beta, sorry, gamma function property. Okay, this is our gamma function property. I'm going to use here gamma function. So we need to write n gamma n, right? This is n gamma n, n gamma n. This one is n plus 1, right? N gamma n. So n gamma of n. This is our formula. The next step again, I'm going to write this one like this. Gamma of n minus 1 divided by 2 minus 1 plus 1 again. So n minus 1 divided by 2. So if you simplify this factor, n minus 3 divided by 2 plus 1. Again, you need to use gamma function property here. Okay. N minus 1 divided by 2. This one, n minus 3 divided by 2. Gamma of n minus 3 divided by 2. We can write up to n term also here. Okay. So therefore, I'm going to write this expansion series like this. You write keep on these things up to 5, 1 divided by 2, 3 divided by 2. The next one is n minus 5 divided by 2, right? Next one is n minus 7 divided by 2, gamma of gamma of n minus 7 divided by, right? So you need to extend this one. So n minus 7 divided by 2 also there here. Okay, no problem. I'm going to write this equation like this up to 5 only. Okay, for simplification. 1 divided by 2, n minus 3 divided by 2, n minus 5 divided by 2, gamma of n minus 5 divided by 2. So in case if you decrease these values, then you can expand this one, 3 divided by 2, and the term also. Final one you can get gamma of 1 divided. So this is the final term. Okay, you need to expand this one like this. Finally you will get 5 divided by 3, I mean 7 divided by 2, 9 divided by 2, 3 divided by 2, 1 divided by 2, gamma of 1 divided. So we know gamma of 1 divided by 2 equal to root pi. Then we need to rearrange this form. Finally we can get final answer. So gamma of n plus 1 divided by 2 equal to this. I am going to write n minus 1, n minus 3, n minus 5, gamma of n minus 5, and so on, 5 comma 3 comma 1, gamma of 1 divided by 2 equal to root. So whole divided by two is there, 2 power n. So therefore 2 power n, gamma of n plus 1 divided by 2 equal to n minus 1, n minus 3, n minus 5, gamma of n minus 5, and so on, 5, 3, 1, root pi. So this is our answer. Okay. Next problem. Prove that integral 0 to 1, 1 minus x whole power n, whole power 1 divided by n dx equal to 1 divided by n, gamma of 1 divided by n whole square divided by 2 into gamma of 2 divided by n. So remember this formula. This formula is very, very important, especially for solving WKB approximation method problems. It is very useful formula. So please remember this one. Okay. So I'm going to solve this equation first. I'm going to take LHS side of this equation. Integral 0 to 1, 1 minus x whole power n whole power 1 divided by n dx is right. So let us take x power n equal to sine square theta. Okay. Now you can derive this equation with respect to x dx equal to. So it is better to wait. Yeah. So I'm going to write only x term. So if I write x equal to sine 2 divided by n theta, right? Now it is better to derive with respect to x. Dx is equal to n and x power n minus 1, right? 2 divided by n sine 2 divided by n minus 1 theta, and this is x, our x, cos theta d theta. Now use limits. Okay. Put x equal to 0 here. Okay. Sine theta equal to 0, right? Then theta equal to 0. This is our lower limit, right? Upper limit. Put x equal to 1 in the equation. Sine theta equal to 1. Then theta equal to pi divided by. Okay. Now I'm going to substitute all this information here. Okay. Better to give, I'm going to bracket this like this. Okay. Not using any equation numbers because these are all properties of beta and gamma. So you need to substitute x power in place of x power n sine square theta dx place of dx 2 divided by n sine 2 divided by n minus 1 theta cos theta d theta. Then substitute these limits. Okay. Now I'm going to substitute limits. So this is our equation, right? 0 to 1. 1 minus x power n whole power 1 divided by n dx equal to integral 0 to pi divided by 2 1 minus x power n, this is our sine square theta whole power 1 divided by n. Place of dx 2 divided by n sine 2 divided by n minus 1 theta cos theta d theta, right? Now we need to simplify this equation. Integral 0 to pi divided by 2 cos square theta, this one, okay, whole power 1 divided by n sine 2 divided by n minus 1 theta cos theta d theta. Next step is this one. If you look at here, cos square theta whole power 1 divided by n plus 1. This one sine 2 divided by n minus 1 theta d theta. So we know one important formula. Zero to I divided by 2 cos 2m minus 1 theta sin 2n minus 1 theta d theta equal to gamma of m gamma of n divided by 2 gamma of m plus beta and gamma relation. So this is the important formula. So I'm going to use this formula here. Okay. So after rearranging this equation, I'm going to use this formula. 2 divided by n is there already. Then 0 to pi divided by 2. This one cos 2 divided by n plus 1 theta sin 2 divided by n minus 1 theta d theta. So we need to use this formula. Cos in place of n, we have only 1 divided by n plus 1 is there here, right? So it's better to write this one. 2 divided by n. Okay. This one gamma of 1 divided by n plus 1, right? Okay. This one here gamma of 1 divided by n, right? Okay. Divided by 2 into gamma of 1 divided by n plus 1, 1 divided by. So if you simplify this one, 2 divided by n, this one we can write n gamma n, right? 1 divided by n, gamma of 1 divided by n, gamma of 1 divided by n divided by 2 into 2 divided by n plus 1. Then final two steps are the 2 divided by n, 1 divided by n is here, gamma of 1 divided by n whole square divided by this one also we can write gamma of n, right? Gamma n, 2 divided by n, gamma of 2 divided by n. This one cancel, and only we have this final equation. 1 divided by n, gamma of 1 divided by n whole square divided by 2 into gamma of 2 divided by n. This is our final answer. So go on. Yeah, this is our final. Okay. Next problem also means similar type of problem. show that integral 0 to 1 x power m minus 1 into 1 minus x power a whole power n dx equal to 1 divided by a n factorial gamma of m divided by a divided by gamma of m divided by a plus n plus 1. So this is also very important formula. This formula maybe we are using WKB approximation method shortcut. Okay, now I'm going to solve this equation. I'm going to take LHS side first. Integral 0 to 1 x power m minus 1 1 minus x power a whole power n dx. Put x power a equal to sine square theta. Then x equal to sine 2 divided by a theta. Now differentiate this one. Dx equal to 2 divided by a sine 2 divided by 1 theta n into x power n minus 1, right? Limits are going to change like this. Put equal to 0, sine theta equal to 0, theta equal to 0. This is lower limit, upper limit equal to 1, sine theta equal to 1, theta equal to I divided. So use this same method, same formula, you can get answer. So because this one is important relation, therefore I'm going to solve integral 0 to 1 x power m minus 1 into 1 minus xa whole power n dx equal to integral 0 to I divided by 2 because lower limit our upper limit. Sine 2 divided by a theta whole power m minus 1 into 1 minus sine 2 divided by a theta whole power a whole power n into dx is 2 divided by a sine 2 divided by a minus theta cos theta d theta. Then solve this equation. 2 divided by a 0 to pi divided by 2 sine 2 divided by a m minus 1 theta again sine a, right? A, right? This theta. Okay. So here A gets cancelled. Here carefully we need to write this thing. Okay. Minus 2 divided by A plus 2 divided by A theta. Okay. Then cos 2n plus 1 theta d theta. Here few steps are there in between this step and this. So I skip this. Easy after solving this equation, you'll get definitely this. Okay. So finally, we'll get 2 divided by A, 0 to 5 divided by 2 sine 2 divided by A m minus 1 theta cos this one going to 1. Okay. 2n plus 1 theta d theta. So then use this similar formula which we previous problem 5 divided by 2 cos 2m minus 1 theta sine 2n minus 1 theta d theta equal to gamma of n gamma of m divided by 2 gamma of m plus n. After using this formula, I got this. Okay? It's direct formula, right? So need to use this formula. Okay? Divided by 2 gamma of m divided by a plus. So this is our form. Main form 0 to 1 x power m minus 1 1 minus x power n whole power n. So this is our formula. Main answer. This formula is very and one more uh, problem is there. One is legendary duplicate formula for gamma function. Very important. After one, I'm going to discuss legendary differential equation. So this Lagrange duplicate formula, after solving this Lagrange duplicate formula, I mean uh, duplicate formula for a gamma function, Lagrange duplicate formula. So we need to discuss next class the Lagrangian polynomial. Next problem is to obtain Lagrange duplication formula for gamma function. To obtain the Lagrange duplication formula for gamma function. Okay. So this one or else this is the Lagrangian formula. Gamma of 2x equal to 2 power 2x minus 1 divided by root pi gamma of x plus 1 divided. This is our Lagrange duplication formula for gamma function. Okay, Lagrangian for gamma function. These are all properties are very solve physics problem. So for that we need to take first beta gamma relation. Okay, solution of this equation beta of x comma y. So this is our beta and gamma relation, well known beta and gamma relation. So simply I'm using x and y. Maybe in previous class I used m and okay. So put y equal to x, y equal to x1. Okay, just use the two terms. Then you'll get gamma of x divided by x plus x. Beta of x comma x equal to gamma of x whole square divided by gamma of 2x. So this is our equation number 1. Now use basic definition of beta function x comma y. So integral 0 to 1 e power x minus 1 into 1 minus t y minus 1 dt, right? So generally we are using this formula, right? This is our known form, integral 0 to 1 x power m minus 1 to 1 minus x power n minus dx. Just for convenience, I'm going to use t and x. Okay? So don't confuse this thing. Just simply I'm using x and y. Again here also put y equal to x, then t equal to 1 plus s divided by 2, then dt equal to 1 divided by 2 t. Now limits are going to change like this. Limits, so use limits t equal to 0, then s equal to 1, right? If you use t equal to 1, you'll get s equal to minus 1. These are the limits. Now I'm going to use all this information here, comma y is better to here also, because to y equal to x, right? Going to use this of y equal to, then lower limit is minus 1 to 1 1 plus s divided by 2, because t is equal to 1 plus s divided by 2 whole power x minus 1, then 1 minus x, right? 1 minus t whole power y minus 1, right? 1 plus s divided by 2 whole power minus 1, place of dt 1 divided by 2 ds. Okay, then simplify this equation. 1 divided by 2, 1 to 1, 1 plus s divided by 2 whole power x minus 1, 2 minus 1 s divided by 2 whole power s minus 1 d. Then 1 divided by 2 integral minus 1 to plus 1, 1 plus s divided by 2 whole power x minus 1, 1 minus s divided by 2 whole power x minus 1 d. We need to simplify this one carefully. 1 divided by 2 integral minus 1, 1 square minus square divided by 2 power square x minus 1, then 1 divided by 2 integral minus 1, 1, 1 minus x minus 1 divided by 2 power 2x minus 1, then 1 divided by 2 integral to 1. It is better to write this denominator value 1 divided by into power 2x minus 1 because relation with respect to ds is 1 minus s square whole power x minus 1 ds. Okay. Then 2 1 divided by 2 into 2 power 2x minus 1. I'm going to interchange this one 0 to 1. Then we can use this to start to 1 minus s square power 1. So this one going to cancel. Okay. You just wait. Yeah. This is 2 square 1x minus 2. So we forgot here this 2, right? 2. Okay. Then 2 is there already. 1 extra 2 is this one going to cancel 1 1 2 minus 1 here already 3 are in start. Now it is okay. This is our equation 2 integral 0 to 1 1 minus s whole square s x minus 1 divided by 2 power 2x minus 1 ds. Now again going to by this one put u equal to s square, then s equal to u power 1 divided ds equal to 1 divided by 2 u power 1 divided by 2 minus 1. We use this information here 0 1 1 minus u x minus 1 divided by 2 power 2x minus 1 1 divided by 2 u power minus 1 divided by 2 du. Zero to 1 minus u x minus 1 divided by 2 power x minus 1 u power minus 1 divided by 2 dx. Then 1 divided by 2 power 2x minus 1 equal 0 to 1 minus whole power x minus 1 u power 1 minus. So this is our gamma function, right? So I'm going to use gamma function. That's it. X comma x equal to 1 divided by power 2x minus 1. This is our beta and gamma relation function. Gamma of x, gamma of 1 divided by 2 divided by gamma of x plus 1 divided. So this is our beta and gamma relation. This is our equation number 2. Now compare equation number 1 and compare equation number 1 and yes, if you look at the equation number 1, beta of x comma x equal to gamma of x whole square divided by gamma of 2x, right? Then equation number 2, compare these two equations. Comparing equation number 1 and equation number 2, gamma whole square divided by gamma of 2x equal to 1 divided by 2 power 2x 1 gamma of x gamma of 1 divided by 2 divided by gamma of x plus 1. Cancel these two things. Only we'll get gamma of x divided by gamma of x equal to 1 divided by 2 power 2 minus 1 gamma of 1 divided by gamma of x plus 1 divided by 2. Okay, or gamma of x plus 1 divided by 2 divided by gamma of x equal to root pi because of 1 divided by 2 by 2 power 2x minus, or else you can write this one gamma 2x equal to 2 power 2x minus 1 by root pi gamma of x plus 1 divided. This is very very important. This called legendary duplication formula. Lagrange formula.